Hello friends, welcome back. In this tutorial we will study about CSMA. The full form of CSMA is Carrier Sense Multiple Access. This carrier sense multiple access is a random access method. Now what is the random access method? We have already studied about it in previous tutorial. Now this CSMA, this method is based on principle sense before transmit. In this method, each station has to first listen to the medium before sending. Now, what happens this CSMA? This method can reduce the possibility of collision, right? Because the chance of collision can be reduced if a station senses the medium before trying to use it, right? Now what happens, the stations are connected to a shared channel, and the possibility of a collision still exists because of propagation delay, right? Now what happens when a station sends a frame, then it still takes time for the first bit to reach every station. Therefore it takes time for every station to sense it, right? Therefore a station may sense the medium and find it idle, right? Because the first bit sent by another station has not yet been received, right? Now let us see an example. It will be clear after this example. Suppose at time t1, station B senses the medium and finds it idle. Therefore it sends frame. Now at time t2, the first bits from station B has not reached station C, right? Now what happens at time t2? The first bits from station B has not reached station C. So at time t2, when station C senses the medium, it finds it idle. Therefore station C also sends a frame, right? Then what will happen? Then there will be a collision. The two signals will collide and both frames will be destroyed, right? Now the next topic is vulnerable time. Now what is this vulnerable time? About vulnerable time we have already studied in previous tutorial, right? So what happens? The vulnerable time of CSMA is the propagation time TP, right? Now what is this propagation time? The propagation time is the time needed for a signal to propagate from one end of the medium to the another, right? Propagation time is the time which is needed for a signal to propagate from one end of the medium to the another. So what happens when a station sends a frame, right, and any other station tries to send the frame in the vulnerable time, then the collision will occur, right? See what happens when a station sends a frame, right, and any other station tries to send the frame in the vulnerable time, then the collision will occur, right? Now what happens if the first bit of frame reaches the end of the medium? Then every station will have heard the bit and they will not send frame, right? Now what the station will do if the channel is busy, and what the station will do if the channel is idle. Now there are three methods. First one is one persistent method, right? First we will discuss one persistent method. Now what happens in one persistent method? In one persistent method, what happens? The station sends its frame immediately with probability 1 after it finds the line idle, right? So what happens in this case? If a station has to send a frame and it finds the line idle, then the station will send its frame immediately with probability 1, right? And in this method the chances of collision are highest because two or more stations may find the line idle and send their frames immediately, right? In this case what happened in this method? The chances of collision are highest. Why? Because two or more stations may find the line idle, right, at the same time and send their frames immediately, right? Now next is non-persistent method, right? Now what happens in non-persistent method? In non-persistent method, a station that has a frame to send senses the line, right? If the line is idle, it sends the frame immediately, and if the line is not idle, it waits a random amount of time and then senses the line again, right? Now what happens, the third method is p persistent method. This method is used when the channel has time slots with the slot duration equal to or greater than the maximum propagation time. Now what happens in this method, after the station finds the line idle, it follows these steps. Now the first step is written here, that with probability p, the station sends its frame. Now the second step, it is written here, with the probability q is equal to 1 minus p. The station waits for the beginning of the next time slot and checks the line again, right? Now when it checks the line again and it finds the line idle, right, then what will happen? Then we will go to step 1, right? Again we will go to step 1, right? And if the line is busy, right, so what happens, when it checks again and it finds that the line is busy, then what will happen? Then it acts as a collision has occurred and uses the backoff procedure, right? So what happens, if it finds that the line is busy, then it acts as a like that the collision has occurred and it uses the backoff procedure. It waits random amount of time and starts again, right?